So as the name of the chapter goes, it's called as mathematical physics, right? Why do we call it as mathematical physics? Is because these are the mathematical concepts we are going to use in most of the physics concepts. That's it, as simple as that, right? So this is the name of the chapter. See, I'm sure you would have learned the concepts of differentiation and integration, right? Is that what they started with? Right. First, differentiation means this thing. These are the formulae. This is what you need to do, right? But that's not how you learn it. Okay. So before you learn the concept of differentiation, see, going forward, whatever you learn, right, I'll give you the reason behind why you're learning and how you're supposed to learn. Okay. So if you see, the first concept that we need to learn before differentiation is called as slope of a line. Okay, it's called as slope, right? So let's take this remote for instance. Okay, and let me take my hand as a flat surface. So if I keep the remote on top of this, right, how is it appealing with respect to your eyes? Is it not horizontal? Is it not exactly horizontal? So if I take the same remote, instead of inclining both, if I keep my hand like this and I incline this remote with respect to my hand, can you say that this remote is making some angle with respect to my hand? You're able to see an angle here, right? So meaning of it is, if I take this key, for instance, I keep on top of it, I keep on the top of the horizontal surface, it is going to rest. Whereas if I try to bend it like this, what is happening? It is sliding, right? Because what was happening in the first scenario? It was flat. Whereas in the second scenario, it is inclined, right? The best example for this is when you go for the shopping malls or something, right? You would have seen the parking lots are always kept at the bottom. So you either go down the slope or you come up the slope, right? So to visualize it, basically slope means if there is an inclination of a surface with respect to a horizontal. Can I say that? Are you able to visualize what I'm saying? So if I take this to be the horizontal surface, and if there is an inclination of the surface with respect to the horizontal, let me call this as theta, then I can say that this line is at a particular slope. Or I can call this inclination itself as a slope. Right? Can I say? Right. Now, basically what happens here is, if there is one line like this, if there is another line like this, right? If one of the lines is fixed and the other line is rotated with respect to it, then we get a parameter called as an angle. So basically, how do you define angle? If someone says angle is 60 degrees, what is the meaning of it? Incline means what? So the angle is defined between whom? Angle is basically defined between two lines. So what you actually do is, if I keep this finger as one of the lines and this marker as the other line, right? If I rotate it like this, can I say this stylus is making an angle with respect to the horizontal? Means, can I say it is rotated with respect to a fixed line? Right. And one more important thing that needs to be addressed here is, in which direction is this line getting rotated? So with respect to you, which direction is this? It is rotating in this way. This is called as anti-clockwise, or you call it as counterclockwise, right? What about this direction then? It is going to be clockwise, right? This is simple. Now, going forward, whenever I speak about angles, right, I'll ask you whether the angle is positive or negative. So in mathematics, an angle is said to be positive if the measurement is made in the anti-clockwise direction. Am I clear with this? Similarly, an angle is said to be negative when the rotation is made in the clockwise direction. Am I clear with this? So what I'm doing is, I am marking something like this. I'm not just putting that arc, rather I'm putting an arrow mark. So here it is positive angle. Am I clear with this? Right. Now listen to this. Now, how do you define this slope of a line? So this line is making an angle with the horizontal, right? So slope of a line is defined like this. Tangent of the positive angle made by a line with horizontal. So what is it? tangent of the positive angle made by the line with the horizontal. Are you able to understand what I'm saying? Now, when this is going to be the scenario, right? Listen to this carefully. What is this tangent I'm trying to speak about? It is tan. Tan of theta is what is called as slope of this line. The slope of line is always represented with the symbol small m. Okay. Tan theta is going to be equal to small m, right? So this is what we call it as slope of a line, right? This is a basic definition. Are you able to visualize what is slope? Right? Are you able to see? Right. See, had the line been horizontal with respect to this, then what would be the value of theta? 0. So slope would have been tan 0, means it is 0. So what is the slope of the horizontal? Slope of the horizontal is 0. Had this line been exactly perpendicular to the horizontal, then what would be the tan 90 is what? Undefined. So slope of y-axis, slope of something which is vertical is not defined. Because it comes out to be tan 90, no? No, slope is not an angle. Slope is tangent of the angle. Slope is a number. Right? So that's why this word is very important. It is the tangent of the positive angle. By here, don't get confused. What do I mean by positive angle? Positive angle means the angle which is measured in the counterclockwise direction. Am I clear with this? So this is an important point to be noted. Right? So having said this, I am going to extend this concept to a coordinate geometry. That is, if I take the basic coordinate system like this, x-axis, y-axis, x dash and y dash. Okay. Then what I'm going to do is, I am going to draw a line like this. And on this line, I will take 2 points. Let me call it as x1, comma y1. And let me call the other point as x2, comma y2. Okay. Now my job is to define the slope of this line. So for that, what I need to do is I will extend it like this. Then I will see what is the angle it is making with respect to the horizontal. So I'm very clear. I didn't say positive x-axis. I told only horizontal. When I say horizontal, the axis can either be positive or negative. Right? Don't get confused that positive. So you told positive, then why didn't you take it in the first quadrant? No. Okay. So having said this, from here, if I drop a perpendicular, and from here, if I drop a perpendicular, right? Then what is this distance going to be? This is x1. Am I right? So what about this distance? Obviously, x2. So what about this distance? So if I drop a perpendicular from here, then what is this distance? It is y1. Then what is this distance? y2. So y2 is basically the distance from the x-axis, and y1 is also the distance from the x-axis. So here I have tan theta. So logic is very simple. Trigonometry clearly says it is applicable only for right angle triangles, right? So what I need to do is, in this part which is looking like a trapezium, I'm going to construct a right angle triangle. So when I construct a right angle triangle, it will be something like this. Means from this point I have dropped a perpendicular. So let me call this point as A, let me call this point as B, and let me call this point as P. So if this distance is x2, this is x1, then how much is this distance going to be? If this distance is y2, this is y1, then how much is y2 minus y1? So if I take the triangle B, P, and A, so if I take the triangle BPA, what is BP? Y2 minus y1. What is AP? X2 minus x1. Then what is this angle? It is theta. Because if this is theta, this is also theta. Why? They are corresponding angles. Am I clear with this? Now tell me, what is tan theta from this? What is tan theta? opposite divided by adjacent. So it is BP divided by AP. Then it is going to give me y2 minus y1 divided by x2 minus x1. This is tan theta. If you observe this, can I write y2 minus y1 as difference in the y coordinates? So in physics, difference is represented by the symbol delta. So this triangle is called as delta. So delta y divided by delta x. So basically, if you know 2 points on a line and somebody asks you to write the slope of the line, what will you write it as? It is the difference in the y coordinates divided by the corresponding difference in the x coordinate. What do I mean by corresponding? If I write y2 minus y1, I should write only x2 minus x1 in the denominator. I should not change the order of the subscript. Meaning, I cannot write y2 minus y1 here and x1 minus x2 here. That is wrong. So that is why it is defined as a ratio of the difference in the y coordinates to the difference to the corresponding difference in the x coordinate. Right? So tan theta will be equal to delta y by delta x, and this is going to be the slope of line joining 2 points. Right? Make a note of this. I'll tell you where you will apply this. Make a note of this. It will connect it. But good that you observed it. I wanted to ask that question. You would have learned differentiation as dy by dx. No? I'll tell you what is. That is the reason why I started with this. You will understand it. Why is differentiation important? And for you to understand differentiation, why slope is important? I'll connect the dots. Okay, till here it is clear. No? Right? It's very simple. Basically, if someone gives you a line, see how much is what is the angle made by that line with the horizontal in which direction? In the positive direction. Always measure the anti-clockwise angle. Take tan of that anti-clockwise angle. That is slope. That's it. Okay. So this is something like an extended formula that we are deriving, provided you know 2 points instead of you sitting and measuring. Means if 2 points are known to you, right, you need not use a protractor. You directly can use this formula y2 minus y1 by x2 minus x1. Basically, when you use a protractor, it becomes a Euclidean geometry. Here it becomes coordinate geometry. That's the only difference. It's this point. It's point B. Let me do an example problem based on this. See, example. Suppose I give you 2 points, A 2, 5, B 7, minus 2. Okay, some random points. Right? There is a line passing through these 2 points, and I ask you what is the slope of this. So M will be equal to, what will you write? So y2 minus y1 divided by x2 minus x1. So this is y2. Minus 2 minus 5 divided by 7 minus 2. Am I clear with this? So what is the answer going to come out to be? It is minus 7 divided by 5. So slope of the line in this scenario is going to be minus 7 by 5. I told you, no, it's just a number. If you do y1 minus y2 by x1 minus x2 also, you'll get the same answer. Check and see. y1 minus y2, you can do it 5 plus 2. 5 minus of minus 2. 5 plus 2, 7 divided by 2 minus 7, minus 5. So that's what I've given. Slope of line joining 2 points. I've already given it to you. So since now you know if a straight line is given and 2 points on those straight lines are given, you know how to find the slope of that line. Right? Now the next point that we are supposed to know before knowing differentiation is not all the shapes in this world is only going to be a straight line. Right? See, what if you have a shape like this? For this kind of a shape, is there a possibility where you can define the slope for it? Yes, you can do that. You can do that provided you need to draw something for it. I'll tell you what that something is. Okay. Before that, I need to explain you the concept of something called as functions. So I'm going to explain you what is a concept called as function. I'll simplify it as much as possible. Okay. I'm not going to give you more technical definitions or anything. I'll just give a simpler definition. See, in your lower grades, if I give something like this, P of x is equal to 2x square plus 3x plus 1. Right? Something like this was given. What is this? Basically, it's a, what polynomial is this? So it's a quadratic polynomial, right? Now, if I ask you what is P of 2, what will you do? Wherever x is there, you will put the 2. Right? You will just plug in that value and tell me a number, no? 2 into 2 square plus 3 into 2 plus 1. So how much are you going to get? 4 into 2, 8. 8 plus 6 plus 1. It's going to give me a 15. Means the value of this quadratic polynomial at 2 is 15. Right? Or if I put x is equal to, I'm getting 15. Now, can you tell me what is the significance of this? What is the mathematical significance of this kind of a value? You used one word. You called it as a quadratic polynomial. Right? So, if I take this and draw it on a graph sheet, if I take this expression and plot it on a graph sheet, what does a quadratic polynomial give us? Quadratic polynomial is not a straight, it's a parabola. So, ax square plus bx plus c is a parabola. So, when I talk about parabola, you can either have an upward parabola like this or a downward parabola like this. Right? So, when will you have an upward parabola? When the coefficient of x square, that is a, is greater than 0. When will you have a downward parabola? When the value of a is less than 0. I hope it's clear, right? Now, tell me one thing. Find the discriminant of this and tell me, is it coming out to be 0, positive or negative? What is the discriminant of this? B square minus 4ac. So, b square is 9 minus 4 into 2 into 1. So, what is it? It is 1. It's a positive value, right? So, positive value means it is going to have 2 real and distinct roots, right? I'm not concerned about roots. Suppose I say the graph is like this. I'm not getting into the details of whether this is right or wrong. I know that there are 2 roots. I don't know where they are. I'm not bothered about it in this context. Okay. Now, if I have a point 2, 0 here. Why did I take 2, 0? Because I took the x value as 2. So, if I drop a line like this, a vertical line like this, then this line is cutting this parabola, right? Then the coordinate of the line where this line, the coordinate of the point where the line cuts the parabola is given as 2, 15. See, this is 2, 0. I'm just dropping a vertical line. Why did I drop a vertical line? Is because I need to know how much is the distance from the x-axis. So this line is cutting this parabola at a particular point. So what is going to be the coordinate of that point? It will be 2, 15. How did I tell that? Because when I substituted 2 in that equation, this equation is basically this graph only. Theoretically, it's an equation. When you draw it on a graph sheet, it is the shape. It is going to take the shape of a parabola. Am I clear with this? So, for this shape, at the point 2, when the x coordinate is 2, what did I get the corresponding y coordinate as? 15. Suppose I have p of 1. What is the answer going to be? So, 2 plus 3 plus 1. How much is it going to be? 6. For example, like I don't know where that point is. Suppose this is 1, 0. Random points. Okay. Then what is the meaning of this? If I draw a vertical line, then the vertical line will construct a point which is going to give me 1, 6. Am I clear? Are you able to visualize what is the meaning of the values you had been finding till now? Right. Similarly, when you have a cubic polynomial, right? Then for that shape, you substitute the value of x, right? You will get the corresponding value of y. Now, what do I have to do with this in terms of function is what the question is. So, you learned this p of x, right? How do you pronounce it? You call it as p of x. No, this is polynomial of variable x, polynomial of one variable. That is, the variable is x. In a similar way, if I write y is equal to f of x, right? Then I will call this as a function where this will be a function of one variable. As you keep changing the input variable, you will get different outputs. Meaning, as you keep giving the value of x inside, you will be getting the value of y so that you can plot something like this on the graph sheet. No, because see, the left side, right, what will be the least value that you can substitute on the real number? Minus infinity. So when you substitute minus infinity, right, the value will go to plus infinity. Because minus infinity the whole square. Minus infinity means I'm talking about a very big number. The square of that is going to be even more big. So this value is greater than this. So this will lead to plus infinity. This side also will lead to plus infinity. That's the reason. That is why it doesn't have any endpoints on the sides. Okay. So am I clear with this? Now, see, I've just given you the basic definition of what is function. I didn't even give you the definition. I told you what is a function. Basically, you write it as y is equal to f of x, where y is called as the dependent variable, x is called as the independent variable. Why do we call it as independent? Is because we are free to substitute the value of x. Nobody says you can keep substituting the value of x. For that, what will happen is you will get the corresponding values in the y. Okay, this is what a function is. So basically, a function behaves in such a way that you give one input, you will get one output. You're able to understand? So input is given as x, output is taken as y. So depending on what kind of function you're defining, you will be giving a prefix to it. For example, this in your 9th grade, you would have learned it as polynomial. But in your 11th grade, you will learn the same thing as a polynomial function. Is that clear? So instead of f, you have p, but x is the same. X is a variable. Instead of x, you can use z also. It's up to you. But in common notation, we use y and x as the combination, where y is taken to be the dependent variable, x is taken to be the independent variable. This thing is very important for you to understand differentiation. Again, I'm repeating it. Is that clear? See, suppose, what did I call this as? What function is this? Polynomial function. It's a polynomial function. See, last year you would have learned sine theta, right? Instead of sine theta, if I write y is equal to sine of, in the place of theta, if I replace it with x, sine is what kind of a variable? It's a trigonometric variable. So that is a prefix you need to add. You call it as, so instead of theta, if you write it as x, this is called as a trigonometric function. Similarly, y is equal to tan x. This is a trigonometric function. That's it. Okay. That angle is variable. If that angle is a variable, okay, then so if one value depends on the other, then it is said to be a function. So that you give one input, you take one out. Independent means, see, for example, y is equal to 2. This is also a function. You call it as a constant function. Because, why do you call it as constant function? Because this side there is no variable, it's a constant value. 2 is a fixed number. You call it as a constant function. See, in your 9th grade, you would have had this question. Is 2 a polynomial or not? Is 2 a polynomial? Yes. Why do you call it as polynomial? You can write it as 2 into x power 0. It is a constant polynomial, but still it is a polynomial. Similarly, the polynomial is replaced with function when you come to 11th standard. You call it as a constant function. You need not go deep into this. When I come to the concept of functions, I'll explain it in depth. As of now, if you understand this much, it is enough. So basically, if there is a particular mathematical equation given to you, you give one input, you get one output. You call it as a function as of. That is your understanding. Right? So the function can take any shape it needs. It need not be a parabola. It need not be a straight line. It can be of any shape, depending on what function I'm defining. If I need to understand how this differentiation works, why did I even speak about slope of a line and function before coming to differentiation? It is basically differentiation. I would call it like this. It is basically the combination of those two. I told you, right? Slope is defined for whom? Slope is defined only for a straight line. But if at all you have a curve like this, if somebody asks you to define the slope of it, then you need to draw a tangent at that point. You draw a tangent at that point, right? The slope of the tangent at that point, I'll come to this. Slope of the tangent at the point is what is called as dy by dx. Means delta is replaced with d. D. It's an infinitesimally small value. I'll tell you why this happens. So that is why when you talk about a curve, slope is defined at a point. So dy by dx means slope of the tangent. What did I mention? Slope of the tangent at the point. I didn't say slope of the tangent and leave it. Okay, but you need to understand why this is happening. Listen to this carefully. If suppose I have a shape like this. Suppose I have a shape like this, which is x and y. Right? If I draw a line like this, it is a line, it is not a chord. It's not a line segment. So if I draw a line like this, if I take this point to be A and this point to be B, right? Then what is the name given to this line? Any idea? What is the name of a line which cuts the curve at more than one point? Sorry? It's called secant. It's called as a secant. So when will a secant become a chord? When it becomes a line segment. You're able to understand? So line which cuts the curve at more than one point is called as a secant. Right? Now, if I keep this point fixed, right? What I'm going to do is I will draw another line in this way. Let me call this as B dash. Now what has happened? This point B has traveled towards B dash in this direction. Are you able to see that the distance between them has decreased? Right. So can I call this as a line? Can I call this as a line? Means on the curve, I took 2 points. Let them be x1, y1, and let this be x2, y2. Will I be able to define the slope of AB? What is the slope of AB? Delta y by y2 minus y1 by x2 minus x1. Right. Now A is fixed, which is x1, y1. B prime is, let me call it as x3, y3. Now I'll be able to define the slope for it. Will I be able to define the slope for AB dash? Yes, I can define. Now what I'll do is I'll move this B dash even more closer to A. Let me call it as B double dash. Right. So as I keep this point fixed and as I move this B closer to point A, what is happening to that secant? So the distance is decreasing first of all, and at one point, as you keep moving closer, right, that secant will become a tangent. So you define the slope of the secant, right? As you kept moving closer, you're still defining the slope of the secant only. But how did that secant become? It became a tangent. A and B will be very close to each other. They'll not coincide. They'll be very, very, very close to each other that you need 1000x zoom to see how close they are. Let's say you put it under a microscope and see, right? They'll be very close to each other, but if you see with the naked eye, it will appear as if it is a tangent. So this differentiation falls under a branch of mathematics called as calculus. And this calculus, what is actually happening is, here also what did you find? Actually, what did I say? Slope of the tangent at that point, right? But that's an approximate value. You're actually finding the slope of secant. But how is that secant appearing to our eyes? It as a tangent because A and B are very, 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 very close to each other. So that is why you call those kind of values as infinitesimally small. This is how it is written. So dy by dx is basically delta y by delta x only, provided the distance between x is small. You write it like this, don't get scared. I'll just tell you what it is. You know it is enough. So it is called as limit delta x tends to 0. You read it as limit delta x tends to 0. Delta y by delta x is what is called as dy by dx. So to put it very simple, differentiation and slope, they both are same. Right. But when will you differentiate? I'll come to that. But when will you differentiate? When you need to find when you don't have a straight line in the first place, right? Means when you don't have a straight line, you draw a tangent at that point and find the slope of the tangent. That is what is called as dy by dx. So it will take some time for you to understand. Don't overthink. I told you I'll give you the reason. I gave it. Okay, you will understand it slowly. This is very high on the first thing. Okay, so don't think too much. Your job is only to know the formula, apply it. Where to apply it, I'll teach you. But all these things, I'm building it because maybe after 3-4 months down the line, once your maturity levels increase, you will be able to understand. You will. Is that point clear? See, if at all, I know it is tough because you have not seen these kind of, I directly went into calculus. Calculus directly from 10th to 11th is not the right thing. But as of now, know what is the reason. If somebody asks you why you differentiate, right? What will you say? This is the answer. If somebody puts a question to you, tell me why do you differentiate? What will you say? I'm differentiating to find the slope of the tangent to a curve at a particular point. That's it. What is the answer? To find the slope of the tangent to whom? To a curve at a particular point. That is what you're doing. Okay, if I directly tell you what is slope, you would have not understood. That is why I had to come from the basics. Now, is that registered? Because I'll tell you what people do now when somebody asks why you differentiate to make the value small. That's not the right answer. You don't differentiate to make the value small. You are no one to make the value small. When the values are small, you differentiate. Right? To find something called as instantaneous value. So first learn this. I'll give you the set of formulae. I'll relate it to physics, then you will understand. So by the end of the session, I promise you will understand why you're doing it. Okay. Please make a note of this. Delta x tends to 0. Tends to 0, na, meaning I told you, A and B are not the same points. A and B will be so close to each other that they appear to us like they are the same points. They are not. Calculus is approximation. Calculus is not exact value. It is an approximate value, meaning, yes. So when that is why it is not equal to, it is tending to 0, meaning this will be 0 point, let's say some 100 zeros and a 1. It is that small. You will substitute, but actual meaning is this. See, because you cannot take what is that approximate value. See, somebody tends to 0. For you, it can be 0 point, 100 zeros and a 1. For me, it can be 0 point, 101 zeros and a 1. So which value will you take? Then it will be a debatable topic. That is why you substitute the value. I repeat, calculus is approximation. It's not exact value. Especially differentiation. That's not how the story starts, right? That's not how the discovery went. See, the concept is somebody started with a secant. They raised a question, same question which you asked, when slope is defined only for a straight line, then what about curves? Can we not define the straight line as slope at all? Is what they thought of. Then what they did is they kept one of the points fixed. They started moving the other point along the curve, so that the distance between the points slowly started decreasing. And at one point, it became in such a way that the distance between them is so small that the secant itself will appear like a. You need not do this at all. You will not do this. You know the formula, you'll apply it. That's it. But I'm saying how that formula has come because of that. I'm explaining what is the significance of. Because I don't want you to be like the other guy saying the differentiation make the value small. It's an insult to me. Somebody asks you, say you're finding the slope of a tangent to a curve at a particular. See, if you know finite values, if there is a finite difference existing between the readings, then you will take delta. If the value is small, then you will take differentiation. I told you, by the end of the session, you will get the answer to everything. Because delta and D appear to be same, but there is a slight difference. I'll come to that. Differentiation is done to find the slope of a tangent to a curve, at a particular point. limit. You read it as limit delta x tends to 0. You can write it down. First, tends is an arrow mark. Rightward arrow mark. Limit is the one which leads to differentiation. Now we can't explain limits. Function a heavy topic. Limits okay, as of now, just know that something like this exists. Okay, I'll give you the set of formulae, use it, then we'll connect it to physics and understand when to use differentiation, when to use. So that your third chapter becomes easy. So all these things will start with your third chapter. D is called as derivative. Derivative. You read it as derivative of y with respect to x. You read it as derivative of y with WRT means with respect to x. So basically the numerator is the variable, denominator is the numerator is a dependent function, denominator is an independent function. I told you y is equal to f of x. No, the y is always in the numerator, x is the denominator. Suppose you can ask me a question, sir, can't we define x is equal to f of y? You can. That's up to you. But whenever you write something like this, you're trying to tell the reader that left side value is dependent, right side value is independent. For example, I gave you a question, no, x is equal to, so what is the difference? I just change the values. I just change the variables. But here, if they take the exact meaning of x and y, right, then the x and the y coordinate will get interchanged. You're able to understand? Right. So if I want to differentiate this, right, I'll not write it as dy by dx. I'll write it as dx. Because derivative of dependent variable with respect to the independent variable. Now, based on the different kinds of functions that we have, right? Based on the functions that we have, there are some values which are actually derived. As of now, we need not know. Whatever is needed for physics alone, I'll take. Okay. So here I'll write it like this: function, which is f of x, or I'll call it as y also. Y or f of x being the same. And here the output of differentiation is called as derivative. Okay. Suppose I have a function like this, x power n. The derivative of this function is given as n into x power n minus 1. Okay. I told you, don't ask me the reason. Now I can't tell also. You need to know binomial theorem and all those things for you to derive. As of now, don't worry also. It's not a part of your headache. So x power n is nx power n minus 1. Suppose I have a constant. Derivative of a constant is always 0. But derivative of constant multiplied with x power n is not 0. Meaning, see, for example, if I have a constant multiplied with x power n, so d by dx of c into x power n, you cannot write it as 0. What you actually do is, whenever it's a multiplication factor, you take the c outside, you take the constant outside, and you'll write it as d by dx of x power n. So answer will be c into, use this expression, n into x power n minus 1. It's a multiplication factor, coefficient. So it's constant multiplied with. Okay. As of now, I'll use an into mark, but going forward, I'll not use it. Into, basically, we use it only for cross products. Right. So here, whenever you have a bracket, into a bracket, it is like one value multiplied with other. So the answer here is going to be constant multiplied with nx power n minus 1. Am I clear with this? Right? Then derivative of sin x is cos x. And derivative of cos x is minus sin x. Am I clear with this? Right. As of now, make a note of these values. Till this step, is it clear? Now, see, sometimes what happens is, like how a constant is getting multiplied with a function. X power n is a function. Accepted? Right? X is a variable. That variable is raised to the power n. It's some function. So it is not always necessary you will either have only x power n or only constant or constant multiplied with x power n. Sometimes there can be the algebraic operation that is taking place between two functions. For example, that we call it as algebra of functions. Okay. Suppose I have a function f of x plus g of x, and I am interested to find the derivative of it. Right? If I'm interested to find the derivative of it, then let me call this f of x plus g of x as some y. Then dy by dx in this scenario is given as d by dx of f of x plus d by dx of g of x. Now listen. When I have y is equal to f of x, right? Listen to this carefully. Then I can write dy by dx as d by dx of f of x. This is one way of writing. Or I can write this as f dash of x. This is another way of writing. Or I can write this as y dash. Or I can write this as y with a dot on top of it. Everything means differentiation. Everything means differentiation, and this is called as the first derivative. Means you're differentiating the function once. You can ask me a question, can I differentiate the function second time also? You can. It's called second order derivative. If you do it three times, you call it as third order derivative. Okay, just to extend this concept, if at all you differentiate the function twice, then you will have something like this: d square y by dx square, which is also written as d by dx of f of x, or this can also be written as f double dash of x. 2 dash on top of f represents you differentiate it twice, or it can also be written as y double dash, or it can also be written as y with 2 dots on top of it. Similarly, 3. It keeps going like this. We generally don't use this. If it is d cube by dx cube, then you'll write as f triple dash of x, y triple dash, y with 3 dots on top of it. Okay, this is just a notation. Just a notation. Okay. So having said this, what I'll do is going forward, I'll be using the dash notation. So I will write this as f dash of x plus g dash of x. I hope you are able to understand this. Now, it is not necessary that you always add the functions. You can subtract them also. Okay. But before that, let me take an example. For example, if I have y is equal to x square plus sin x. You know the derivative of x square? You know the derivative of sin x. So, dy by dx is y dash is equal to, what is the derivative of x square? How did we get the 2x? Because for x power n, it is n into x power n minus 1. N is how much? 2. X power n minus 1. 2 minus 1 is 1. So basically, you put that number here and decrease the power by 1. For example, I'll tell you a shorter way. Suppose it is x power 4. Put the number there, write x and decrease the power by 1. So 4x cubed. It is going to be 2x plus. What is the derivative of sin x? So that's it. This is all you need to do. Am I clear with this? Similarly, y is equal to f of x plus g of x is there. No. You can also have, this is the first one. You can also have y is equal to f of x minus g of x. Right. Then what will y dash be equal to? F dash of x minus g dash of x. Means if I take the same functions with a negative sign, So y is equal to, if I have x square minus sin x, then what is y dash going to be? That's it. Simple, no? Right? These two aren't they simple? Right? So make a note of this. The next algebra of functions is, and the derivative here, I can have the product of two functions, f of x into g of x. If I call this as y, then y dash is written as, see, generally you write it like this. Listen to this. This is first function, second function. Okay, this is what we do in our mind. There are multiple ways in which it is given in books. Some books will give you as u into v. Okay, so basically what happens is first function into derivative of second function plus second function into derivative of first function. You follow a pattern. So what you do is, basically it is u into v dash, u into derivative of v plus v into derivative of u. So instead of u and v, I used f of x and g of x. Am I clear with this? Right? Okay. So if I take an example, for example, y is equal to, if I take x square sin x, I'm using the same combination of functions, x square sin x. So this is first, this is second, or if you have learned it as u and v, you can take this also, right? So y dash will be first function into derivative of second function. What is the derivative of sin x? Cos x plus second function into derivative of first function. Done. This answer. Okay. And this kind of a rule is called as, you call it as product rule. So when will you apply product rule? When you have product of two functions. When one function is multiplied with another, we use the concept of product rule, right? And let me explain the last one, then you can make a note of it. And the last operation that you have is y is equal to f of x divided by g of x. You call it as quotient rule. Then what will y dash be? G of x into derivative of numerator. So basically, denominator into derivative of numerator, you have to follow an order. Minus numerator into derivative of denominator, the whole divided by g of x, the whole square. Okay. So whenever you're doing this y is equal to f of x by g of x, right, you need to mention a condition saying that g of x is not equal to 0. It's something like rational numbers only. This is called as a rational function. It's called as rational function. Basically, it will be a rational function. Sorry, my mistake. So you can call this as a rational function if the numerator and denominator are polynomial functions. The numerator and denominator both are polynomial functions, then you call it as a rational function. Whereas what is rational number? Integer by integer, where both the integers are co-primes. Denominator should not be equal to 0. Similarly, here the denominator function should not generate a 0. Okay, for that you need to know the concept of domain, which you learn in relations and functions in your mathematics. As of now, you have this in your mind. So if I take an example, y is equal to x square divided by sin x. Okay, what is y dash? Y dash is sin x into derivative of x square, which is going to be 2x minus x square into derivative of sin x, which is going to be cos x, the whole divided by sin x the whole square. Sin x the whole square is sin square x, not sin x square. You should not square the angle, you should square the function. Okay. So this will be 2x into sin x minus x square into cos x, the whole divided by, call it as sin square x, which is going to be y. Sorry, y dash. I hope it is clear. So what do you call this as? You call this as a quotient rule. So basically you have two rules. What are they? Product rule and the quotient, right? So you can make a note of this. There is another rule called as chain rule, which looks similar to product rule, but it's not. So product rule is defined when function is multiplied with another function. Whereas chain rule is used when a function is used within another function. Are you able to understand the difference between both? So here, f of x is a function, g of x is a function, f of x into g of x is the product of two functions. Whereas here what you have is f of g of x, meaning if suppose I have x square as one function, which I call it as f of x, okay, suppose I call f of x as x square, g of x as sin x. The meaning of this statement is x square into sin x. Whereas the meaning of this statement is f of g of x is there, no. So wherever x is there in f, I need to replace it with g of x. So f of g of x here means in the place of x, I'll replace with g of x. So it is sin x the whole square, it is sin square x. Am I clear? So whenever you have this kind of a function, you need to use something called as chain rule. I'll tell you how to use it. Okay. So this kind of a function is called as a composite function. Just for you to know the name, it's called as composite function, whereas this one is product of functions. Seriya? Listen. So y is equal to, for example, I have this sin square x. Then what I need to do is, see for this one, if this is there, no. Y is equal to f of g of x is there, no. So y dash will be f dash of g of x into g dash of x. Okay, let me simplify it. Say you have y is equal to sin 2x, for instance. See, sin x is the function. Sin of, whenever you have this kind of thing, it will become a composite function because it is not one here. Then how do you do this is y dash is equal to, you differentiate the main function. What is the main function here? Sin. What is the derivative of sin? You write cos, but you don't write cos x. You will write derivative of g of x. You will write it as cos 2x into, you will differentiate this 2x. This is the answer. This is called as chain rule. Okay, this you will not use it mostly as of now. There you will use it maybe in the 4th chapter. That too, I'll teach you one derivation of my own method. At that time, I'll show you how to use this. But as of now, if you know this, it's enough. Okay. So just to clarify, if suppose I have y is equal to, let's say, cos 7x. So what is y dash? Minus sin of, write the value as it is. 7x into derivative of 7x. Sorry. Into 7. That's the answer. So you finally report it as minus 7 times sin 7x. This is called as chain rule. Why I told it looks similar is because you are multiplying only. It looks similar. Right? I hope it is clear, no? Right. Make a note of this. Okay. That's why, see, I don't want to stress much on this one. Once you understand the basics, right, I'll teach you how to do it. Maybe 5 to 10 examples, you yourself will solve it. Not a big deal. You need not wait till 12th. Okay. But one thing is, let's first understand the basics. Because I know too much of information I've gone today. You need to work on those things. Right. But I promise you that I'll make you understand why we are studying this with the help of physics. Right? See. In your lower grades, you would have seen this equation V is equal to U plus AT. What is this? It is basically one of the equations of motion. Right? This is one of the equations of motion. Under what concept? When an object is moving under constant acceleration. When an object is moving under constant acceleration. Am I right? Now see, what is the basic definition of acceleration? Just to recollect, what is the basic definition of acceleration? It is called as rate of change of velocity. This you know already. So A is equal to, how can I write it? Rate means something changing with respect to time. So with respect to means that should be the denominator. So you put delta t. And what is changing with respect to time? Velocity. So change is always represented with delta. So delta v divided by delta t is acceleration. Okay. Then, is there a way I can write the acceleration as dv by dt according to differentiation? Can I do it? Can I write it? Yes. But the question is, when should I write this? When should I write this? So you need to have that clarity. So if you see A is equal to delta V by delta T, no, this is written for average value. Whereas differentiation is written for instantaneous value. It is written for instantaneous value. So let me explain what I'm trying to say. So V is equal to U plus AT, right? Observe. If I bring U to the other side, then V minus U is equal to A into T. So V minus U divided by T minus 0 is equal to A. Why did I write T minus 0? I brought the T to the denominator. Instead of T, I wrote it as T minus 0. So V minus U is delta V. T minus 0 is delta T. This is what acceleration is. I just reversed the process. Because I wrote only T in the denominator. So if I need difference, I need a value. I have to write something minus something. That the other something is 0. So I wrote it as delta V by delta T as acceleration. As of now, I hope this is clear. But the same thing, V is equal to U plus AT. Instead of dy by dx, in the place of y you have V, in the place of x you have t. So if I write this as dv by dt, then this will be equal to derivative of u plus derivative of at, the first algebra of functions. That's what I was about to say. U is a constant because initial velocity is fixed. So this is going to be 0. So this formula is derived when the acceleration is constant. So when a constant is multiplied with a variable, what can you do? You can bring the constant outside. So this will be a into derivative of t with respect to derivative of t. Derivative of t with respect to time is 1. But what is a? You're able to understand. So in this case, you found the instantaneous value. So when you differentiate something, right? When you differentiate a value, whether it is physics or mathematics, you are finding the instantaneous value. So the preposition used is very simple. So what they say is, I told you, differentiation is done to find slope of tangent so if you see the word at, you need to differentiate. slope of line between 2 points. If you see the word between, you will directly find the slope, which is going to give you the average value. This is what you need to do. So now you understood when to use slope formula and when to use differentiation formula, right? When will you use? Wherever you are asked to calculate average value, you will use slope. Average means you will know some finite amount of differences. Whereas at some places, whenever you are asked to find the instantaneous values, you differentiate. Here. So, but both, they are going to give you the slope only, but they have a different context. Is the point clear? So you can make a note of this. So listen, for the first one, y is equal to x power 5 sin x, no. So dy by dx will be equal to, why is it not writing at this point? Okay. So it is x power 5 sin x, no. First function into derivative of second function, that is cos x, plus second function into derivative of first function, which is going to be 5x power 4. Right. So this is the answer. So answer is supposed to be, you can write it like this also. X power 4, I'll take it common. I'll write x cos x plus 5 sin x. This is another way of writing. Okay, this is one way. Second, y is equal to x square divided by cos x. So dy by dx will be denominator cos x into derivative of x square, that is 2x, minus x square into derivative of cos x, which is minus sin x, the whole divided by cos square x. Right. So I hope this is clear. Right.
Yes, sir. So, sorry, sir.
That's what I told you. So y is equal to tan x is there, no? So y will be equal to, can I write it as sin x divided by cos x? So dy by dx will be equal to cos x into derivative of sin x is cos x minus sin x into derivative of cos x is minus sin x, the whole divided by cos square x. This is minus of minuses, the whole divided by, answer will be 1 divided by cos square x, answer will be, that's it. It is secant square x. Right, now you understood why you got that value.
Yes, sir. We need to take tan x as sin x by cos x, then we use quotient rule to get
Exactly. Exactly. So this is the quotient rule. Right. What about the next question? So the next one is y is equal to 2x cube into tan x. Now you can use, since you know the formula, now here you can use secant square x. So dy by dx is equal to, 2 is a constant, I will not disturb it. X cube into derivative of tan x is secant square x plus tan x into derivative of x cube is 3x square. So answer is going to be, if I take the x square outside, 2x square into x secant square x plus 3 tan x. That's it. That's fine. See, I'm not saying this is how you need to write. Without bracket, you write also, it is correct. Okay. So the fifth one. What is the fifth one? So y is equal to cosecant x, right? See, cosecant x, you can write it as 1 divided by sin x. So dy by dx will be equal to sin x into derivative of 1, which is a 0, because it's a constant, minus 1 into derivative of sin x is going to be cos x, the whole divided by sin square x. This value is 0. So it is going to be minus cos x divided by sin square x, which I'll write it as sin x into 1 divided by sin x. So cos x by sin x is minus cot x, 1 by sin x is cosecant x. So you would have learned this as minus cosecant x cot x. This is the reason why you got it. Here. Am I clear with this? Yeah. So next one. So sixth one is y is equal to secant x. So y is equal to, can I write it as 1 divided by cos x? So dy by dx will be cos x into derivative of 1 is 0, minus 1 into derivative of cos x is minus sin x, the whole divided by cos square x. So this value is going to be a 0, minus of minus is plus. So I'll get sin x divided by cos square x. So you can write as sin x by cos x into 1 by cos x. So sin x divided by cos x into 1 divided by cos x. So 1 by cos x is secant x, sin x by cos x is tan x. So secant x into tan x is what is going to be the answer. Am I clear with this? Right. Now, we'll go to the next concept, that is integration. So, integration is also the reverse process of differentiation. Right. So, for example, if I have dy by dx is equal to x square, meaning, let's say I have y is equal to x cube by 3. Had the function been y is equal to x cube by 3, differentiate this function and see, you will get dy by dx is equal to x square, because you will get 3x square by 3, 3 and 3 will get cancelled, it is x square, right? Now the question is, when you call this as an equation, right, it is an algebraic equation, or yeah, this is called as differential equation. So what is it called as? It's called as differential equation because equal to symbol is used and you have a derivative. So if they give you the equation and ask you the differential equation, you will differentiate. If they give you the differential equation and ask back the function, you need to integrate. So to integrate, what you do is, this dy by dx is there, no, which is x square. This dy is also a variable, dx is also a variable. You will take the dx to the other side, right? Then you will write dy is equal to x square times dx. And this kind of a process is called as variables separable method, because you separated the variables. You separated y on one side, x on other side. Okay. So if I need to eliminate this d, right, then I need to use an operation like this, which looks in the form of an elongated s. If you take s and pull it, no, you will get a symbol, and that symbol is read as integral of dy is equal to integral of x square dx. Am I clear with this? Right? So integral of dy is equal to integral of x square dx. So basically, this is the operation of integration. I'm not going to tell you what is the answer as of now. This is the process, right? You understood where does differentiation come from? Basically, you will have a function. From that function, if you need the derivative, differentiate it. If they give you the derivative and ask you the function, do the reverse process, which is integration. So integrate it, right? So before you integrate, you follow this method. What is this called as? It's called as variable separable method, meaning you separate the variables on either of the sides. Am I clear with this? Right. So based on this kind of an operation, there are certain formulae that we need to know. So here I will take the integral and here I'll get the function. Okay. So integral of x power n. If somebody gives you a question like this, it is meaningless. So you need integral of x power n with respect to which variable? So it is dx. So integral of x power n dx is going to be equal to x power n plus 1 divided by n plus 1. Right. So this is a point to be noted. And another important point to be noted is whenever you have this integral without limits. So integral without limits is said to be indefinite integration. Integral with limits is called as definite integration. So when you write the limits, right, you put a here, b here, or any other variable. Where this a is called as the, you call it as the lower limit, and you call this b as the, that's it. You call it as the upper limit. So it is going to be x power n plus 1 divided by n plus 1. So whenever you do indefinite integration, you need to add a constant to it. Okay. The reason why we do that is because this is there, no. So this is the function. If I have to get back this question, then what I need to do is see if this is given on integrating x power n, I got x power n plus 1. So it is like this. On integrating x power n, on integration of x power n, I got x power n plus 1 by n plus 1. So from x power n plus 1 by n plus 1, if I need to get xn, I need to follow the reverse process, which is called as differentiation, right? So if I ask you to differentiate this, what will you tell me? D by dx of x power n plus 1 divided by n plus 1 plus c. So this is one function, this is another function, right? So what will I get? Derivative of x power n plus 1 by n plus 1 is going to be n plus 1 into x power n the whole divided by n plus 1, because n plus 1 is a constant. So what should I integrate? What should I differentiate? Only x power n plus 1. So derivative of x power n plus 1 is n plus 1 into x power, reduce the power by 1, x power n the whole divided by this n plus 1. N plus 1 and n plus 1 will get cancelled. Plus, what is the derivative of a constant? 0. So on differentiating this x power n plus 1 by n plus 1, what is it you got? X power n, you got this function back. You would have got it, but you need to add that constancy because we don't know the limits. Meaning, if I differentiate this function also, I'm getting x power n. If I differentiate x power n by n plus 1 plus 1, I'll get the same answer. Plus 2, I'll get the same answer. So unless you don't know what is the variable that is getting added, you should not leave that constant. You will leave that constant only in the case of definite integrals because you know the limits between which you are integrating. Whereas here you don't know the limits, it can be any function. So that is the reason why we add a constant, we don't multiply a constant, right? So this is the reason for which a constant is added only in which condition? When you do the indefinite integration. Whenever you do definite integration, you will not add the constant. That I'll tell you how to handle it. Am I clear with this idea? Right. Now listen to this carefully. I'll give you the function and its integral value. So integral of x power n dx is going to give us x power n plus 1 by n plus 1 plus c. So integral of, if I have sin x, integral of sin x is minus cos x plus c. If I have cos x, I'll get sin x plus c. So you're able to understand this? So it will exactly be reversed, meaning you don't have a perfect derivation for this. Only thing is, for the function that you have, if you differentiate, you should get back the question. For example, derivative of only cos x is minus sin x. To eliminate that minus, we add a minus here. That is why you get plus sin x. Derivative of sin x is cos x. Right? So this is how it works. Right? As of now, if you know these three, that is more than sufficient. Okay, I'm going to tell you what is the significance of definite integration. For example, when I asked you a question of what is the significance of differentiation, what will you tell? To find the slope of a tangent to a curve at a given point. Similarly, there is a meaning of this definite integration as well. I'll tell you what it means. Suppose I take a function to be like this, some random function. So I take this is y is equal to f of x. Let me take a limit here as a and let me take the limit here as b. These limits corresponding to the x coordinate. Okay, I'll take this as a comma 0 and let this be b comma 0 so that you will understand it better. Am I clear with this? Now, if I drop a perpendicular from here and let me call it as some x. Okay, let me call it as some x. Now, I'll take another point which is very close to this point, so that I take that point to be x plus h comma 0. Okay, to be more specific, I'll take it as x plus dx comma 0. X plus dx comma 0, where dx is this distance, which is a very small value. Okay. Now, if I take this box, then what shape does this box take? It looks like a trapezium, right? But it can be approximated to a rectangle because these 2 points are very close to each other, so that this height and this height are the same. Am I clear with this? So this curvature is ignored because of the distance between these two verticals. So if this is x, what would be the corresponding point here? So what would be the corresponding point here? Is it not going to be x comma f of x? You take this x and substitute it here. It is going to be x comma f of x, right? So how much is this height? It is going to be f of x. Now, if I ask you what is the area of shaded rectangle, what is going to be the area of the shaded rectangle? What is the area of shaded rectangle?
X comma f of x into f of x.
So it is basically this thickness. So how much is this thickness? This point is x comma 0. This point is x plus dx comma 0. So what is the difference between these 2 points? So this difference is going to be dx. It is only that much thick, right? Dx is a very small quantity, right? So area of the shaded rectangle is equal to f of x into dx. Can I write it like that? F of x into dx, right? Now, how many such rectangles of this small quantity can I find between the points A and B? So how many can I find? So now is it clear? F of x into dx. Like this, how many such thinnest rectangles you can find between A and B? You're going to have infinite such, right? So listen to this carefully. In your lower grades, you would have learned something like this. You will use sigma when the data is discrete. Where do you use the sigma? In statistics. So in statistics, how is the data taken? Like for example, x1, x2, x3, all these data are discrete data, right? So you will use sigma xi where I is varying from 1 to n, right, like this. So what is the meaning of this? You will have x1 plus x2 plus so on till xn. So what is that you are able to observe from this? Sigma I is equal to 1. What is this basically? This is the lower limit and I is equal to n is the upper limit, right? I is equal to 1 to n x of I, where xi is the variable, this is equal to sum of all these values. Am I clear with this? Now what you are going to do is, you will use a sigma when you have discrete data in your hand, whereas here you have continuous data, meaning you have infinite such rectangles which are attached to each other. So whenever you have continuous values, then to find the area made by curve, so area made by curve with x-axis, you write it like this. The sigma is replaced with the symbol of integration because you are adding. Integral of this area, okay, like integral of all these small areas between which 2 points? Between the points A to B. So when you do definite integration, what is that we are actually obtaining? We are actually obtaining the area made by the curve with the x-axis. So to be more specific, it is not always necessary that the area is calculated only with x-axis. To be more specific, I would say area made by the curve with the independent axis. So how to find that independent axis is, look at the variable that is there within f and look at the variable with respect to which you are integrating. So if you do a to b integral of f of x dx, and this is what is going to be called as definite integration. Am I clear with this point? Find the integral of x power 5 dx between 1 to 2. Find the integral of sin x dx between 0 to, as of now I am writing it as 90 degrees, but you should write it in terms of radian. It's pi by 2. Did you learn about radians also? 90. Okay.
Sir, can you repeat what you just said? Did you learn about
Radians.
radians?
Yeah.
Yes, sir.
Then it's fine. Then I'll write it as pi by 2 itself. So integral of, yes, it is going to be x power 6 divided by 6 between the points 1 to 2. So 2 power 6 is going to be 64 by 6 minus 1 divided by 6. You are going to get 63 by 6 square units. So integral of sin x is going to be minus cos x between 0 to pi by 2. Right. So this is going to be minus cos pi by 2 plus cos 0. Why did I put a plus here? Because minus of minus. So cos pi by 2 is going to be a 0 and cos 0 is 1. Right. So integral of cos x is going to be sin x between 0 to pi by 2. Answer is going to be the upper limit, that is sin pi by 2 minus sin 0. So sin pi by 2 is 1 minus sin 0 is 0. So answer will be 1. That's it. Okay. So all these things are values.
Sir, but what about like log and
As of now, not needed. I told you, I am teaching you only whatever is needed for physics. Okay. Log, exponential and everything, as of now, you don't need it. It confuse you.